I'm Daniel. I'm an AI engineer, software developer, and also a tech mentor at We Can Code. Also a tech mentor. So I'm into building AI solutions, making use of artificial intelligence, especially generative AI, and of course LLMs. So we can really get quick to what we are doing today. It's introduction to building generative AI and LLMs. So we are going to be making use of pre-trained and pre-existing models to use it to build our project, just something very simple and pretty much interesting. But before we get into the interesting part of the project, let's quickly take a look at some interesting parts of generative AI. So now we have the generative landscape. And as we all know, generative AI is divided into different parts. It's divided into different parts, and one of the parts we know very much is that of ChatGPT, where we have generative AI that helps to create and generate texts. And also we have Gemini, we have Llama, we have Claude, and so many others. We have so many others. I believe we've heard of DeepSeek and the likes of them. But now we can see just right in front of the generative AI companies and the likes of it, we can see output modalities just by the side. So what's just a little bit of description on what's happening here is that we can see text, images, code, audio, and video. So that means all those generative AI platform, well, we call all these frontier models, they have the power to generate texts. They have the power to generate images, code, audio, and of course, video. And we call all those functionalities multimodal. That means they are doing far more than one simplistic generation. So not just text alone, but they can generate maybe images, they can generate code, they are even able to generate audio, video, and the likes of it. So we call it multimodal. And as we've already gone through, we must have heard of Google's Gemini, Meta's Llama, and Claude. So moving on to the next, we can see the generative shifts. We can see the generative shift. So we can see I believe some years back, a lot of us must have heard of some tools like Grammarly. We might have heard of Quillbot. So back then, a lot of people, well, AI was not so popular then, especially generative AI, the way it is now. But back then, we might have wondered what was going on. So the shift started from completion, paraphrasing, where you use all this AI to just you give it a string of text or characters, and then it paraphrases it, probably make it shorter and make it more readable. So that is where we add the chatbots and completion. But we didn't even really have chatbots. We had completion. Sorry about that. Sorry, okay. Yeah, we had completion. So that was something that helps you to complete your text, something that helps you to paraphrase your text. And we went on to a new to the in the future we had visual synthesis, where we had stuffs like DAL-E, that's models that are able to generate images. We had DAL-E. DAL-E was very popular back some years ago. I think that was around 2021, if I'm not getting it wrong. So it could generate images. We had software generation, and not until a few, probably 2 years ago, where we started seeing, 3 years ago, where we started seeing AI generating solid code. And that was, when we started using stuff like ChatGPT models like ChatGPT, where it could generate software. And we also had multimodal streams, where we could generate software, where we could generate images, where we could, where we could generate software code, we could generate images, we could also generate, we could also make use of chatbots using just a single model. And later on, we started going into video, where we sourced ChatGPT Sora. Now we have Google's VO, just so many other interesting VO3. We have so many other interesting models out there, but we should always respect the shifts, the generative shift. We knew it started from completions, chatbots, then we could generate images, we could generate software, and we eventually started being able to generate all just in a single model. So moving on to the next, we have the atomic unit. So before we can see this depiction here on the screen, but before that, we have to understand that when an AI or an AI model have to work, an AI model is basically a model that's a machine learning model. Now I'm talking about generative AI. It is a machine learning model that makes use of generative capacity. I mean, generative capacity. So that means it's simply a machine learning model that is able to predict. And we all know that machine learning, or we should all know that machine learning is all about prediction, where it takes in and ingests a series or a set of data, and based on that data it's ingested, it's able to give or able to give us the highest probability. So the next time you are chatting with ChatGPT, your favorite AI model, or what have you, we should always know that all what it's doing is predicting the best and giving you the best response after reiterating over billions of times on what the best possible response would have been. So now we can see the atomic unit here, basically how the most basic generative AI model works. So here we have an example, the capital of Nigeria is. So now we should understand that the AI by default, it doesn't know what the capital of Nigeria is, but what it does, it goes through its parameters, it's set up, well done, I want to stay away from speaking about complex stuff here. I want to make it as basic as possible. So what it does, it goes through its large database of data, and then it tries to look for what it learned already. There's a process called training. That is how LLMs, that is how models are able to understand the best predictive outputs. They go through a process called training. So training is basically your model going through a large set of data, which most times is unorganized. It goes through that large set of data, and then it keeps on reiterating over billions and billions of parameters, billions and billions of text numbers, and sometimes even images. When we are talking about multimodal models, it goes through and then it tries to find the best predictive answer. So here we can see the capital of Nigeria is. So we can see in a world, it could be Lagos, it could be Paris, it could be any other country, but because of the model's training parameters, it could get Abuja as the best predictive answer. So that means it has gone through this process. The capital of Nigeria is billions of times. And now, as a result of the results of the billions of times test or training process that's gone through, then it's able to pick Abuja as the best answer, as the best response. So basically, when we are chatting with our models, all it's doing is prediction. From here, we can see Abuja had a 99.8% predictive response, a positive response. So there are stuff we call some things loss functions when during training. So it tries to mitigate and narrow the loss. It tries to narrow and bring down the probability down. So that's why when we are into training models, we have different kinds of parameters we use to train and fine-tune our models, all for one cause, and that cause is to make sure we get the best predictive response. So that's just basically what happens at the back end. And of course, we have what we call transformers. Attention is all you need. So transformers, well, we can always discuss transformers later. It's just a little bit more complex, but transformers is the kind of it's how do I put it? It's the it's like the container or the rules, the set of rules that our generative models pass through. Let's just leave it that way. So we can see here the model does not know fact. It predicts the highest probability completion based on pattern recognition. So next, we can see defining LLMs. We must have heard of LLMs alone, we must have heard of agentic AI a lot, but here we are focused on LLM, which is the core, which is large language model. And as we've already talked about billions of parameters, billions of tokens, billions of words. So it's the first L is large, as we can see, the second is language, and the third is model. So the language is trained on unstructured text and code. So I mentioned already that it goes through a large database of information. I'm just trying to break it as simple as possible. So that's the language. So it could be trained on, it is syntaxes, on just on structured text or whatever it is, but it goes through a large language. And then the model, as we've mentioned, all generative AI, they work on machine learning model, and this model is a deep neural network model, which helps us with probabilistic neural network architecture. So it is a deep neural network model. So at the back of it all are LLMs, are agentic AI, the models that run all this nice and very good frontier models. It's still resting on the basics of machine learning. That is the reason why we will see some things that makes a lot of sense very soon. And we can see training requires reading billions of sentences to converge. So it goes through a very large pool of data, and it has to do this over and over and over and over again, which uses GPU cost, and that is why it's very expensive to build your own model from the scratch. You can train your own model. That's basically it's easier when the model parameters are not so large. But building from the scratch, it requires a lot of GPU power because it runs all this, it reiterates over and over again to make sure it gets the best prediction. So we can see the training cycle. I mentioned already, so we don't forget, training is the process and LLM learns new things. It is the process and LLM is able to get better predictions. So that is what it's called training. It trains. It's like how can I put it? It goes to school. Just allow me to use the context. It goes to school. It learns new stuff. And then it's able to give you, okay, this is what I've learned. Okay, ask me questions now. I will tell you what I've learned after going through over and over again. So we can see the injection part where it reads massive data sets. So your data set could be a lot of books. It could be the whole Wikipedia. It could be so many images. So it goes through this large data set, then it repeats it billions of times. So it keeps on going over and over and over and over again, trying different probabilistic positions. And then, oh, sorry, I just skipped one. Sorry, I skipped one, or even two. Sorry, I took it the wrong way. So we have ingest, and second, we have guess. So that means after reading this massive data set, it predicts the missing words. So we saw the capital of Nigeria is, then it tries to predict based on the data set it's been given. Let's notice this, or let's take this so we don't miss it. When an LLM is training, there are different pairs. We call it questions and answers. So that means an LLM, when you are giving it its data set, the data set has the answer to all sorts of questions. So that means in the data set is trained on, it has the capital of Nigeria is Abuja. It has it already. So now what the LLM does, it goes through that data set over and over again in trying from different standpoints to get the closest response. That is what the transformer model does. We have different kind of models, but the transformer model is what we use for generative AI, especially chatbots. So after it's been able to guess the missing words through going over and over again, then it goes through the correction part. So AI this is called loss function. Of course, when you are training your model, you can always measure the loss function, but we can say that AI, it tries to correct it. So that means during the training process, it actually gets the answer wrong at times. So it keeps on going and going over and over again till it starts to close. It starts to converge and close the losses until it becomes smaller, which makes your AI to be, let me just call it now, smarter. So after the correction phase, and there are different ways to enable correction phase. We have reinforcement learning by human feedback. That's RLHF. But we can always discuss that later. And then we can see it scale. So it scales, it repeats this billions of times until it's able to get a pattern, a standing and trusted pattern. So now the builders toolkit. So what we can see here, we are not going to have to train our LLM from the scratch. I mentioned that is very, very expensive. Very expensive. You have to use thousands of GPUs most times, and we are going to be making use of. We are not going to be also building base models. We are not going to be building base models, but it's possible to build your model off a base model. We are also not, of course, spending millions of dollars on compute today. So what we are going to be using is my favorite platform for testing AI functions for running machine learning models, and that is Kaggle. Will be using Kaggle, and with Kaggle, we'll be making use of Hugging Face, and of course, just some very simple Python scripts. So some people, they do ask, do I have to understand programming to a very large extent to be able to train models, to be able to run models? The answer is no, you just need the simple and basic understanding of Python, like the dictionaries, the functions, and just some other basic parts and syntaxes in Python. So we'll be using a pre-trained model, and we'll be using Kaggle for our cloud environment because Kaggle gives us GPU. Kaggle is fast. And the nice thing about Kaggle is if you can make use of a simple, let's say, Word document, you can make use of Kaggle. It's very simple and very much intuitive. So we can see the inference workflow. We are going to be importing tools from Hugging Face. We will see all this very soon. We are going to load our model. We are going to give it an input text, and we are going to see how AI generation works. We are going to see how AI generation works just off the bat. So we are going to be using Kaggle to load our models. We are going to import our tools from Hugging Face, and we are going to build our AI model. So we can see the ecosystem. Hugging Face as an LLM engineer or anyone who has interest in AI, especially generative AI. Hugging Face should be your go-to, one of your go-to resource when you have to, understand models, go through the latest models, and it's basically like a GitHub of AI models, a repository for weights, data sets, and so many interesting and fun stuff. You can play around with the latest models, you can play around with the latest video models, you can play around with the latest image models and multimodal models and all. And also we have the compute hub, which we'll be using Kaggle because it is free. I've mentioned we have access with GPU. We can have T4 GPUs or P100 GPUs, which are pretty much nice and strong GPUs for running our basic AI models. And it runs on browser, so you don't even have to install the software. So the environment of Kaggle, you require zero setup. You don't have to install anything, and you have GPU. This is the most important part of building anything in AI, the GPU. The GPU, which is more like a graphical processing unit that allows you to run tensors, allows you to use PyTorch. So it basically just allows you to run all those models efficiently and faster. You can of course use your CPU at times, but it can make your system get very hot and it can get extremely frustrating and slow. So it's very good to make use of a system that has a strong GPU and a system that can accommodate our model running easily. So of course, we have the roadmap to deployment. We'll be using pre-trained models, which we'll see very soon. We'll build a nice app. I mean, your first application if you haven't dealt with this already, and we can always deploy it on the web. That is the most interesting part of all these implementations. And we can see here we have Amazon SageMaker. These are cloud models, cloud tools and infrastructures that allow you to run your AI models efficiently. It comes pre-installed or pre-created with AI models. So many AI models like Amazon SageMaker, you can make use of so many AI models on it. That's generative AI models. And okay, let's go on. And okay, let's go on here. So we can see the industry adoption, Copilot, Microsoft, Meta, Google, all of them, they make use of generative AI. And we can see that from this, we can see Llama, we can see AWS, AI Bedrock. These are just basically the industry adoption, how all these big companies have their own kind of AI generative AI model. That's the personal generative AI model that belongs to them legally. Okay. So now we are going to be going to our practical session. This is the most interesting part. The theoretical part is just to give us a form of understanding, which I want to believe a lot of us who have shown interest in generative AI must have understood a lot of all these things before now. So we're going to be very interesting part, and I've made it as simple as possible, where you can just easily run AI models and understand how it works. So give me a second to I have to stop sharing my screen here. Okay, so we have Kaggle here. You just have to visit kaggle.com, sign up, very straightforward. And what you have to do is just click on create, and after creating, you can create a notebook, or you can import an existing notebook, and you can also work on models. You can work on data set if you want to build data sets or make use of existing data sets. And so I have a pre-created model already, which is LLM basic. So I'm just going to click on that. So it loads. This is called an editor for those who are not conversant with Kaggle already. This is called an editor, a Kaggle editor. Very much intuitive, straightforward, and easy to use. Easy to use. Okay. Okay. All right. So yeah, if you want to get your Kaggle machine running, you just have to come to run, start session. Run start session. So I'm going to be starting this session now. It's more like starting your machine. So it takes a while. And after starting session, we can come to the left pane, to the right pane here, and we can see session options. So in the session options, we have to choose our accelerator. That's the GPU we want to make use of. I'm making use of a T4. That's with multiple cores. Yeah, or with multiple, or with two GPUs rather. Yeah, so we can see T4, X2. So that's what we are using. So this is entirely free, but you have 30 hours per week of usage. So that means if you make use of Kaggle, that's your Kaggle time, more than 30 hours in a week, you don't get to use it anymore. And for a particular single straight usage, you have 12 hours. So you can run your machine for 12 hours. And this really helps with when you are trying to fine tune models or train models. It really helps because at times, because of the T4 GPU, which is of course not top tier, but it's very much manageable. If you are trying to train a model, it might take you sometimes 10 hours on Kaggle, and it depends on how large those models are. So if you're trying to, for instance, if you're trying to train a 7 billion model on, let's say, a data set that contains 3,000 question and answer pairs, it might take you nothing less than 7 to 8 hours. That's based on my experience. Okay, so now we should understand that Kaggle, it comes pre-installed with a lot of or with several what's it called? With several models. When I mean models, I'm talking about different Python packages that it comes pre-installed with it. But just for Cargo also comes by default with transformers. But we will be installing. We're still going to just use transformers, so we can get the latest model of transformers, the latest model of transformers. So we just use pip install transformers, and we're also using PyTorch. That's touch Python touch. So we just doing this. What you can do is you can run it just by coming here and clicking run current cell, or you can make use of shift and enter. You press shift and enter. So once I press shift and enter now, we're going to run this particular line, this code block. So shift and enter. So this just operates like our basic command line interface. where we just run code and we see the requirements being downloaded. And when it's done, you can proceed to the next. So we are importing from transformers. What we did here, we installed transformers, and now from Hugging Face, let's take note of that. Transformers is from Hugging Face. This particular transformers is Hugging Face transformers, and this has really been helpful in the generative AI world and LLM world, where it allows you to install, to make use of pre-installed packages and modules. So now we have from transformers import pipeline. So pipeline, Hugging Face pipeline, it comes with a package that helps us to abstract a lot of unnecessary a lot of unnecessary Hugging Face parameters. So there is something called autocausal autocausal LLMs from Hugging Face. So pipeline is a mode that allows us to make sure everything is you in a single. Okay, let me just put it this way: in a simple line of code, you can make use of any Hugging Face model using pipeline. So it makes your code very much cleaner. Even though in pipeline, it still makes use of autocausal LMs call, but what we have here is pipeline helps, especially if it's extremely beginners friendly. So we have from transformers import pipeline. I'm trying to slow down in case some people are trying to follow, so you can catch up. So we have from transformers import pipeline. So pipeline allows us to load the model. Pipeline allows us to decode the loaded model. Pipeline allows us to basically pipeline does all the dirty work behind the scene. It abstracts it, but sometimes if you are probably going deeper into calling models, you might have to use a autocausal. But now we are using pipeline. So from transformers import pipeline. So this is making use of Hugging Face. Hugging Face is pre-installed on Google on Cargo. We can also use Google Colab. That's for our notebook because even at the back end of Cargo, it's making use of Google Colab as it's making use of Colab at the back end. But Cargo is just the front. It just gives us the access to the front end. Okay, so we've imported transformers. And now we move on to the next line. The model we'll be using here is Distill GPT-2. Distill GPT-2. This is just a very small model on Hugging Face. If we visit Hugging Face and we search Distill GPT-2, we would find it. You can make use of any model as long as it's on Hugging Face and it supports the pipeline framework. So we'll be using Distill GPT-2. And what is it just takes two parameters. Well, it can take more than two, but the major parameters here are text generation. So we want to make use of this text generation model that belongs to Distill GPT-2. Just as simple as that. We run, remember, Shift Enter, and then it loads our model. I told you, pipeline helps us to abstract a lot of things. Our tokenization, it helps us to abstract, the loading of the model and the decoding. And once it's done, you can see it loads very quickly because it's a small model, of course. Maybe if you're dealing with a 24 billion parameter model, it might take a pretty long time to load it. But now this is loaded into the GPU, and then we can just simple Python script generator, and then we just put in the parameters. So now we just want to we are using max length here. We can set our length to higher numbers, but because this is just a test, so we want to quickly test the auto completion capability or auto generation capability of this AI model. That's Distill GPT-2, and we've cut the length down to 50 characters, or 50 words rather, 50 tokens. Let's put it 50 tokens. So result, and this has been saved. The answer now that's the result has been saved in this particular result have been saved in this variable here, results. And what we can just do is to print the results, and we can see the answer here. Artificial intelligence is one of the main players, in fact. So we can see it completed that which we kept in here. Artificial intelligence is. So it completed it, is one of the main players in AI. In fact, they are main players in AI. And so right now, yeah, so that is one of the reasons we need to add other parameters at times. We can see it's hallucinating here. Well, we can always discuss hallucinating some other time, but it's literally hallucinating here, and it's not even following the right the right text we gave it, the right max length we gave it here. So that's why some other parameters are very necessary. But regardless of that, we can see this same artificial intelligence. We can also ask this same artificial intelligence test. We can also ask it a question. Explain artificial intelligence to a 10-year-old in 3 simple sentences. So there is something we call prompt engineering, which I'm sure a lot of us are conversant with. Prompt engineering, that is you giving your LLMs, your models, it could be your frontier model, it could be ChatGPT, you giving it a kind of pre-configured instruction should I call it? I can call it syntax. So just giving it a very nice prompt. When I mean a very nice prompt, it's called prompt engineering, where you feed it with words, but the words are structured so as to expect a kind of preferred output. So we can see here, explain artificial intelligence to a 10-year-old in 3 simple sentences. Now, this is well directed or well-directed prompt. So we have different kind of prompting. We have multi-shots and so many others. But this is a well-directed direct prompting, which it gave it 3 simple sentences. So we save the results in the results variable here, and we try printing. So yeah, so we can see explain artificial intelligence to a 10-year-old in 3 simple sentences. The real world AI can learn the rules of the game, and this time it will learn more from the rules and give it just what's it called? Some responses from the still GPT-2. But as I mentioned already, the still GPT-2, it's somewhat hallucinating. So I might have to run the model again because I'm not really satisfied with all this blabbing. The real world AI, and that's something we can also discuss when it comes to hallucination, where AI confidently give you responses and answers like it were the truth, even though it might be false. So it's just more called hallucination. So I'm even glad we're able to see that some LLMs have some cons, and one of the disturbing cons is hallucination. Another disturbing con is black box effect, where people don't understand how it gets its answers. But we can always discuss that some other time. There are just some very interesting concepts when it comes to AI generated responses. But we can see here, by all means, it generated an answer all for all, but it's not really much preferred, which we can also try. So now let's build something more useful. Let's do something more useful. So now we are going to just give a question here. So this is basically how ChatGPT works. You give a question and it gives you an answer back in return. And we mentioned all those models are trained most times on question and answer pairs in their data sets. So question, why is AI important? We save it in the question variable, and now we are just printing. We can see it printed. We are going to print it in this parameter, generator parameter here. Okay. I'm very happy we are seeing this. We are going to run this test real quick again, but we can see we can see the pure. I'm very happy with saying this because most times you would not see this. But we asked our AI, why is AI important and what are we seeing here? I'm not sure. I'm certain that AI will be the next top selling book in the next 5 years. Please, this is not what I'm asking. So I'm really glad we are seeing this here. And one of the reasons why this might have happened was I probably loaded the model wrongly, or not me, the model was probably loaded wrongly when it was trying to pull it from Hugging Face. So you would notice if we run this again, you will find entirely different and probably more constructive answer. And something we should also take note of is that smaller models are more likely to hallucinate. I'm really glad we are seeing this post end, and we can see this doesn't make sense. So even ChatGPT, Gemini, I'm sure a lot of us might have noticed sometimes giving us an answer or even trying to attach something that is not true. But the good thing is that because of those models, they've gone through a lot of training process and overall loops of reinforcement learning and the likes. They are very, they might, you might not really notice a lot of hallucination, but they do hallucinate, especially when you ask it maybe some questions like what is today's date. If it doesn't search the internet, it would confidently tell you maybe the date or the day or the year is 2024 at times. So yeah, we can see this is not right. It's telling me if I'm right, I'm saying that I'm a great writer. So we know something is wrong here. So just to really prove and show us that hallucination is something that really exists. So I'm just going to quickly run this. This will just take us like 2 minutes. Let me clear the cell. And of course, we can just use that to quickly. So I'm going to quickly stop the session. So it reboots the GPU or gives us a different GPU. So let me start the session again. So it happens. It happens a lot, and I'm glad it happens. Yeah, well, the probability it happens, like it would have happened, is not very high, but I'm glad we can see hallucination in its pure form. Okay, I think the GP. Okay, it's still setting up the GPU. You can see it here. Draft session. Okay, it's set. So I'm just going to run all this real quick. I'm not going to take time here. Let's. Okay. From transformers, I mentioned we're importing pipeline. Pipeline helps with back-end abstraction. So it's possible the transformer model was not well loaded. It happens. It happens, and we can't fight that. So let it just quickly import the transformers. I mean, import pipeline. All right, it's done. Let's get generate load our model real quick. It's a very small model. I mentioned for bigger models, it might take a lot of time. So we are storing our generator artificial in just two parameters, the question that we are giving the model and the max length. So don't go more than 50 tokens. That's basically what we are saying there. Okay, so now we can see this is making some sense now. Artificial intelligence is an emerging technology that has been around for decades. The recent discovery of machine that has been using artificial intelligence to analyze humans' response. So the reason why this is very vague and wide is also because we are not using some parameters like top K, top P, and the likes. There are some even the temperature. There are so many interesting things here when fine-tuning your answer, but this is just the raw form. So this is on the second question we asked the other time. Explain intelligent. I mean, artificial intelligence to a 10-year-old in three simple sentences. And yep. So we can see a lot of hallucination. This is because we are not making use of top K, top P. We'll discuss that another time, but we can see after like this is not making sense. This is not making sense down here. It's hallucinating. Why is AI important? Let's see what it gives us here. Yeah, so this is hallucinating for this particular response here also. Okay, it tried to work this time. So the reason why is because we are not using temperature, but I believe the message has been sent. The message has been sent here. That's or rather what we are trying to communicate has been communicated. So now we can use a front end if we wanted to use like Gradio, where we can slap a front end, a UI front end where you can chat with your AI just the way we chat with ChatGPT. Gradio, you just require a few lines of code to merge your organ face model into Gradio that gives you a front end. So well, we can see these responses are not really nice. And we have to make use of other parameters like temperature, set the temperature, and some other interesting things. And as I mentioned, the reason why this might be very much weak is because we are using a very small model. So it's most likely to generate something not really preferable. Not really preferable, but I want to make this as basic as possible so we don't have to go into top K, we don't have to go into temperature to set the response or how long or how well or how random we want the responses to be. But that's basically it. This is basically what happens at the back end. So now you can deploy this maybe on your on the cloud. You can deploy this anywhere. You can use fast API. So anyone with the API link can just send a prompt and then you get an answer. There are so many ways to deploy your AI models, so many ways, but this is basically what just runs. You use pipeline from Hugging Face, you load the model, and we get it running. That's basically it. Okay, that's basically it. Give me a second, please. So from theory to practical applications. So if we are supposed to get the practical application of this, of whatsoever, of everything we've learned so far, we can start by learning Python fundamentals. And I've mentioned we don't have to be very much vast in Python. You just need to understand the basics of Python and the very much important syntaxes of Python. You can explore Kaggle, and with the little exhibition I've just showed, we can see Kaggle is straightforward, and we can check out Hugging Face models. We can just visit. You can visit huggingface.com and see the models it has, and every other interesting thing. Basically, this is just a part of um of LLMs. We didn't build anything from the scratch. We didn't train a model. What we just used was a pre-existing model, which was the Still GPT-2, which is a very small model, and as we can see, very much prone to hallucination without adding key factors like should I call it constraints that controls the preferred answer. That controls the preferred answer. So if we want to see more interesting stuff like how we can fine-tune the model, how we can make it give us desired answer, how we can reduce the randomness of the answer and all, we can always, if something we want to see. But I'm really glad we're able to see hallucination in first hand, and with even though we don't learn anything very much, if we think we haven't learned so much, we can understand hallucination and the concept of hallucination. I believe even a beginner who haven't ever had anything to do with AI understand what just happened, what we call hallucination in AI. So that was basically hallucination, where it confidently gave us an answer, even though the answer was wrong from our own humanly and logical interpretation.